Now, it is time to get started with the program itself. And who better to do that than Edgar Hertwich? He is professor at the Department of Energy and Process Engineering at NTNU and international chair in industrial ecology, that is also at NTNU. His CV is pretty substantial, so it would take too long for me to give you the full picture. Besides, it's much more interesting listening to him directly. However, I would like to mention that he was one of the leading authors of the 5th IPCC assessment report, and he currently leads the work on resource efficiency and climate change of the International Resource Panel. It should come as no surprise though, that resources and materials efficiency and circular economy are important keywords for him. And I know that we're going to hear more about that now, as I'm going to leave the digital screen to him. But I also hope that he will start by reminding us of why we are here now at this webinar today under the umbrella of the energy transition. So, Edgar Hertwich, the digital scene and screen, they are both yours. Take it away.
Good afternoon. I would like to talk about visions for the future with respect to carbon and carbon dioxide emissions related to energy and materials. Now, why are we interested in carbon? Well, on the one hand, carbon provides us with about 80% of the energy that we use on the planet in the form of fossil fuels. On the other hand, carbon dioxide is responsible for about 3/4 of greenhouse gas emissions, which contribute to warming the planet. Since the beginning of the industrial revolutions, the average global temperature has increased by about 1 degree centigrade. World leaders have decided in Paris that they would like to limit the temperature rise to well below 2 degrees centigrade, which is often understood to mean 1.5 degrees. Now, in this figure here, you see two different options to achieve such a limit. We can either reduce CO2 emissions to close to zero within this decade, or we can take a little bit longer time, increasing the CO2 concentration in the atmosphere beyond the limit that would mean reaching 1.5 degree, and then backpedaling, removing CO2 from the atmosphere for the rest of the century. This is a very expensive proposition. In either case, emissions need to be reduced quite drastically. Why am I interested in materials? Well, in addition to energy, in addition to being an energy-intensive industry, material production also has process emissions of CO2, for example, in the reduction of steel or the production of clinker. Greenhouse gas emissions from materials production have increased faster than greenhouse gas emissions from energy production, going from 5 billion tons in 1995 to 11.5 billion tons in 2015. The most important materials in terms of their greenhouse gas emissions are iron and steel and other metals, cement and other non-metallic minerals, and plastics and rubber. There are options to technologically reduce greenhouse gas emissions from these production processes. Just 2 weeks ago, the Swedish Prime Minister opened a pilot facility for the production of steel using hydrogen as a reductant, thus eliminating CO2 from this process. Unfortunately, the company that is the pioneer in the field, Hybrid in Sweden, estimates that they will take another 15 years of development before they can commercialize this technology. During those 15 years, a lot of emissions would be released to the atmosphere from the further production of steel. Also for other materials, there's a lot of facilities that are currently in operation that will remain in operation and whose average life is for the next 25 years. So we expect that emissions from materials production will remain to be high. Our most best chance for reducing emissions related to materials actually comes at the material demand side. We need to dematerialize the economy, looking at material efficiency opportunities. We have led a study by the International Resource Panel, which investigates options for material efficiencies within the residential building sector and the private passenger transport sector. Now, we have looked at 7 important material efficiency strategies at different parts of the life cycle of these products. We have looked at designing products using less materials to provide the product, at using materials that have less greenhouse gas emissions per unit function than the materials that are currently used. For example, using wood as a construction material, at improving the yields during manufacturing processes, thus eliminating manufacturing waste. We've looked at providing more service from the same product, thus requiring fewer products to provide the same service level. We have looked at the issue of product lifetime extension, also increasing the amount of services delivered from the same product. We've investigated the recovery, remanufacturing, and reuse of components from these products, as well as the recycling of the materials at the end of life of the products. Now, this is for residential buildings in the G7 countries. We can see that in 2016, there's a lot of emissions from the energy use in buildings, but there's also a substantial amount of emissions from producing those buildings. As the energy efficiency of buildings increases and the energy supply is decarbonized, in the future, we expect that the greenhouse gas emissions associated with energy use in buildings goes down, and that their relative importance of materials actually increases if nothing is done about it. However, if we employ all the different material efficiency strategies that we have investigated in our study, what we actually see that it's not only that the emissions from the materials can be almost eliminated, but also that emissions related to energy consumption are further reduced. And this is mostly related to the strategy of more intensive use, which has the largest potential. By having to heat or cool less building space, we save materials for constructing the building space, but also for the operational of the buildings. In addition, there are options through material substitution, through enhanced recycling to further reduce those emissions. Similar strategies also apply within the cars sector. So we can use cars more intensively by ride sharing, by car sharing. We can reduce the average size of the vehicles on the street by sharing vehicles, so that we have smaller and trip-appropriate vehicles available for our uses. And there are further opportunities related to the substitution of materials. So my vision for the future is that we will use largely multifamily wooden buildings that are built as net zero energy buildings that have shared facilities, that we will employ shared vehicles of various sizes, and that we will slowly move towards low emissions technologies in material production in the 1930s and from there on. Now you might have checked that who would want this future? And what I see is that a lot of this is happening already. Today in Trondheim, where this picture was taken, the prices for new flats in multi-family residences have gone up and are higher than the prices for individual homes. Thank you.
No, thank you very much, Edgar. It was a bit shorter at the end there. I think you didn't get the chance to say thank you, because I know you probably would have, but you are with us now for a short Q&A session. So you can just turn your camera on and also your microphone. There you are. Hi again, and thank you so much for a very interesting start and presentation. You said it yourself, it's an ongoing trend with people living in smaller and more compact flats and sharing different kinds of services. But I was just wondering, how realistic is it that the majority of us want to live that way in the future?
Well, that's a good question. So I'm a little bit concerned about the fallout from the COVID crisis. Before that, urban living was definitely on the rise, and you could see it on in the real estate market, right? The more urban, the more central a flat was, the faster the prices were going up. And we could see that around the whole world. But what we are observing now is that because of the social distancing, people actually, you know, and the home working, people don't care so much about the city centers, and they have bought the latte machines themselves, and so that's my concern, is that there will be an expansion of living space in the industrialized countries given the potential change of working conditions. But I'm still wondering, I mean, we had this, what is called in geography, agglomeration economies. That means that people create value by interacting with each other. And urban cities would offer that, right? Urban space, because, you know, in the partnership, both of the partners would find a good job and just talk to the right people and have these social interactions that would offer creativity and new solutions. And that was basically the explanation for a lot of the economic growth in the past decade. And such conditions are, of course, furthered by having people in proximity. So my question now with COVID is, can we recreate this in a situation where we also have some degree of social distancing? So maybe instead of all accumulating in Oslo or Manhattan, maybe we should have centers that are spread out through the country, that are not in the millions, but in the hundreds of thousands, where you still have sort of an urban living, but you sort of create distance at the same time. Of course, the picture I showed you intentionally wasn't a high-rise tower, but it was still something that has sort of four or five stories. So we actually find in our modeling that these moderately sized multifamily homes are much more resource efficient than the 30-story towers that China likes to build, right? And so actually resource efficiency isn't this inhumane hundreds, tens of millions of cities.
People factories, in a way. That's what I like to call them.
Yeah.
If they But I'm just thinking, when you're talking now, you do mention China as one example, but I get the sense that what you're talking about is applicable for industrialized countries. But what about the developing countries? I mean, they are, you know, rising to
Right.
well, from poverty and into well, I shouldn't say wealth, but better standard of living. But how can you, I do suspect that a lot of them do feel that they have a pretty intensive use of the space they have available already. So to who is this actually applicable?
Well, it is actually some of the more technical strategies of, building lighter buildings and using wood as a construction material that are more applicable in developing countries because there's more need for new building space that needs to be built. At the same time, of course, I mentioned China and you reacted to it. China now has more living space per capita than the UK does. And it's mostly reinforced concrete and glass. Actually, China is using more than half of the glass in the world within its construction sector. And so you can see how these formerly developing countries now have are bypassing us. And of course, we can't have a repeat of China's development model in India or in sub-Saharan Africa. That would be a catastrophe for the world. At the same time, we see that there's a substantial need for better living standards, and that will mean that there need to be emissions to produce all the buildings and the vehicles that these people actually require for decent living. And we need to reduce our emissions to make space for that.
Edgar, we have to move along into the program, but I have received a couple questions from the audience, and I want you to pick them up now, not answer them, but keep them for the panel discussion later on, because you will be participating in that. So the first one is, could you also give some insight on viability with respect to circular carbon economy? So you can ponder upon that. And another one is easier to reply to, I think, as it's more or less a yes or no question. Wouldn't it be increasing the deforestation rate if we encourage wooden buildings? You can ponder on that as well. Oh, things are popping in now. Yeah, I'm actually going to save a couple of these questions for later because they're really good for the discussion. So thank you so far, Edgar. We're going to see you again later on. And people continue to ask questions through Slido. That is perfect. I'm going to keep these questions as I see them right now. So you can absent yourself for now, Edgar, and we're going to see you later on. Thank you so much.